Hello, I'm Manju and welcome to the second video of this series. In the last video, we talked about data and its importance. Let's move on to our next topic. What is database and why do we need it? A collection of interrelated data or similar kind of data is called a database. Database can mean many forms. For example, a list of stuff that you want to buy from your first paycheck. That's a list database. When you go to a store to buy that stuff, salesman looks into his inventory to check availability. That's a tabular database. On the cash counter, you use your loyalty points for discounts. Your customer information is also a database. Can you think of any other kind of database around you? Now, you might ask, what is so special about databases? Why can't we just use the old method of paper and files? There are a bunch of reasons for the same. Number one, data redundancy. There might be repetition or recurrences of data, and this can't be handled using traditional filing system. Think this as having the same movie at 3 different locations in your hard disk. Such a waste of memory. Number 2. Data security and integrity. Imagine your friend got hold of your hard disk and he copied all your personal stuff and also corrupted your device. Number 3. Concurrent access anomalies. Working on same files with a lot of people will be same as sharing a slow internet connection with a bunch of people. It's slow and useless. Number 4. Inconsistency or incompatibility within different formats. Say you took a movie from a friend in Windows Media Player format, but your cool Macintosh doesn't support that. Hashtag heartbreak. Moving on. Our next topic is database management system and why do we need it? As we speak, data is growing exponentially. In 2011 alone, 1.8 zettabytes or 1.8 trillion gigabytes of data was created. That is equivalent to every US citizen tweeting 3 times per minute for 26,976 years continuously. A study suggests that overall data will grow up to 50 times by the year 2020. With the emergence of social media, these figures are going to go up, resulting in old and current technologies to be obsolete. To work on such a massive amount of data and get useful information out of it, we need a flexible, reliable, secure and fast way to organize this data. Everyone, hail Database Management System or DBMS. DBMS is a collection of related data, that is database, and software tool that allows multiple users to access, store and process data into vital information. There are many types of database management systems, but the most popular is Relational DBMS or RDBMS, and that is our next topic. RDBMS is a collection of tables that are related to one another based on a common field. Let's take an example. The store that you visited earlier would have one table that consists of customer details like customer name, customer ID, other demographics, etc. It would also have a transaction table consisting of customer ID, items purchased, price of each item, etc. Do you think there is any relationship between these tables? Before we get into that, let's look at the fundamental entities of a database. A database consists mainly of tables. So what is a table? A table is a collection of data about a specific topic such as customers, transactions, etc. Each table is made up of rows and columns. Let's see how these look like. Columns. Each column is referred by a specific name and represents facts about each entity. Column is also known as a field. Rows. Values appearing under each field constitute a row. It is also known as a record. An important thing to note over here is a table can have any number of rows but specified number of columns. Let's go back to our customer demographics table. Here, name, customer ID, age, gender, and city are the columns or fields. All the values under these fields form rows or records. Key. A column or a group of columns form a key of a table. These are most important while creating relationships between tables in a database. They can be either primary or foreign key. Primary key. It is a set of one or more fields of a table that uniquely identify each record in a database table. It cannot accept null or duplicate values, and you can only have one primary key in a table. Foreign key. It is a field present in database table that is a primary key in another table. Also, it can accept null and duplicate values. Let's visualize. In our customer demographics table, the field customer ID can be used to uniquely identify each record in the table, hence it becomes the primary key. In our transaction table, the same field is present and can be used to form a relationship between these two tables, hence it becomes the foreign key in the transaction table. Do you know any other type of keys? Google it.
So that's all about data and databases. In the next part, we'll talk about SQL and practical application of DBMS. Stay tuned and be awesome. Bye bye.